Hello, friends. So the first part of our new unit deals with exponents and exponent rules. We're going to do a quick activity to get kind of in the feel of it, and then we're going to go over the specific rules and some examples. So you should see in front of you a paper that looks something like this. A big chart. And for each problem listed, give the expanded form. So this is going to be the number in the base of the power multiplied by itself however many times it tells us, and then determine the simplified exponential form. Remember that exponents tell us how many times something is being multiplied by itself. So 2 to the third is 2 times 2 times 2, and x squared is x times x. So we do have an example here. 2 to the second times 2 to the third. Now the way we would write this in our expanded form, 2 to the second is 2 times 2, 2 to the third, 2 times 2 times 2, and then those are being multiplied together. So to find our exponential form, we add up how many 2's are being multiplied, and that'll get us 2 to the fifth. I'll do another example here, just to give you another idea. So 3 to the fourth is going to be 3 times 3 times 3 times 3. 3 to the second, 3 times 3, 3 times 3. And then those are also being multiplied together. So another multiplication sign there. And now we count up how many 3's we have. 1, 2, 3, 4, 5, 6. Now some of you may remember the exponent rules that we're going to be utilizing in this activity without even knowing it. But if you don't, that's okay. That's why we're doing this, to kind of refresh us and see where they come from. So I'm going to ask you to do the next two sections here. 10 to the third times 10 to the first, and then x squared times x to the third. Go ahead and pause your video and do that real quick. Our next section involves when we have something with an exponent and then in parentheses and then another exponent. So 2 to the third to the second. What this means is that it's 2 to the third being multiplied by itself twice. So our example shows 2 to the third times 2 to the third, or 2 times 2 times 2 times 2 times 2 times 2, for a total of 2 to the sixth. Now again, I'm going to give another example. So 3 to the fourth times, or 3 to the fourth to the second is going to be 3 to the fourth times 3 to the fourth, because we're multiplying the 3 to the fourth by itself twice. So that's going to be 3 times 3 times 3 times 3, 3 times 3 times 3 times 3, for a total of 8 3's multiplied together. So again, go ahead and do these next two following the same idea. So this is going to be 2 to the second multiplied by itself 4 times. This is going to be 8 to the fifth multiplied by itself 2 times. Go ahead and pause now and do that. And then our final section here involves things with exponents on top of each other. So here we have 2 to the fifth over 2 to the second. So 2 to the fifth, 2 times 2 times 2 times 2 times 2, over 2 to the second, 2 times 2. Now the way that we do this is, as we know, anything divided by itself equals 1. So any pair on top of each other we can cancel out. So when we do that, we're left with just 3 2's on the top. 2 times 2 times 2, which simplifies to 2 to the third. So we'll do another one of those. 4 to the sixth. So 4 times 4 times 4 times 4 times 4 times 4, over 4 to the third. 4 times 4 times 4. Oops. Might have to change pens here. Four times 4. And again, since anything divided by itself is 1, we can cancel out anything that we have exactly enough in the top and the bottom. So 3 sets of 4 cancel, and we're left with just 4 times 4 times 4, which is 4 to the third. Now again, go ahead and do these next two. Be careful with this one because we have a larger number, a larger exponent on the bottom, so see if you can figure out what that would mean. But go ahead and try those on your own. So the table on the previous side went through 3 of our common properties of exponents and kind of showed you where they come from. So the first section deals with what's called the product of powers property. And that says that a to any m power times a to any n power. So this is for any number a and any numbers m and n is going to end up being a plus, or a to the m plus n. So, for example, back here we had 2 to the second times 2 to the third, and that ended up being 2 to the fifth. 3 to the fourth plus 3 to the second ended up being 3 to the sixth. We add the exponents when we are multiplying the stuff. So here, x to the fourth times x to the third is going to be x to the 4 plus 3, or x to the seventh. For our more complicated examples, we can use our commutative property of multiplication to rearrange the terms as we like. So because these are kind of squished together like this, that means they're being multiplied. So if it helps you, you can draw lines between the different things that are being multiplied together and rearrange them. So 2 times 6 times x to the third times x to the negative 1 times y to the first times y to the seventh. Anytime we have a variable that does not have an exponent written, the exponent is 1, if that helps you. 2 to the sixth, we know that that's 12, times x to the third times x to the negative 1 is x to the 3 minus 1, so x to the 2, times y to the first times y to the seventh. Again, we're adding the exponents, so that'll be y to the eighth. So our simplified version here is such. And then over here, again, if it helps you, you can kind of separate the things and rearrange them. So, oh, looks like I need to change pens again. That's annoying. So negative 5 doesn't have another number, so we'll just leave it like that. Times x squared doesn't have another x, okay. Y to the first, z squared times z to the third. Go ahead and see if you can finish this one up. The middle section of our table here dealt with what's called the power of a power property. So we had 2 to the third, all of that raised to the second power, which ended up being 2 to the third multiplied by itself twice. And we ended up getting 2 to the sixth. Here we had 3 to the fourth raised to the second, and we got a total of 3 to the eighth. So the power of a power property says that for any number a, m, and n, a to the m further raised to the n equals a to the m times n. So if we have something already with an exponent being raised to another exponent, we multiply the exponents. So here, let's see. We have, and we can split this up. So again, we can split it up as we like. So x to the fourth to the fifth times y to the first to the fifth. X to the fourth to the fifth, we multiply the powers, so that's going to be x to the 20th, and then y to the first times the fifth, that's going to be y to the fifth. Here we have, let's see, 3 to the third times x to the first to the third times y to the second to the third times z to the fifth to the third. So 3 to the third, that's just 3 times 3 times 3, 27. X to the first to the third, x to the third. Y to the second to the third gets us y to the sixth. And z to the fifth to the third gets us z to the 15th. So altogether, 27x cubed, or to the third, y to the sixth, z to the 15th. And then finally, let's see, we've got a little bit more complicated here, but we can still do it. 5 to the second times a to the second squared again, times b to the first to the second. This is getting ridiculous. I keep running out of ink. Three to the second times c to the fourth to the second. So a lot of pieces here, but go ahead and see if you can do this one. Again, it's just going to be multiplying the powers together and simplifying. The third section of our table dealt with what's called the quotient of powers property. So we had 2 to the fifth over 2 to the second, and we ended up with 2 to the third. We had 4 to the sixth over 4 to the third. We ended up with 4 to the third. The quotient of powers property says that for any numbers a, m, and n, a to the m divided by a to the n. So that's technically a to the m over a to the n equals a to the m minus n. So when we have two things with the same base being divided by together, we subtract their exponents. So here, y to the seventh over y to the third, it's going to be y to the seventh minus 3, or y to the fourth. Here, again, we can split things up into the different pieces. So we have 4 times x to the first minus 3, since that's x to the first, and then we're subtracting 3 from it, times y to the second minus 1. You don't have to write it out this way. If you can look and see, okay, well, 4 doesn't have a partner, so that's just going to stay 4. X to the first over x to the third, that's going to get us x to the negative 2. And then y to the second over y to the first is just going to be y. That's also fine. 4x to the negative 2, y. In the next part, we'll get to how to simplify that x to the negative 2. And then here, again, we can split it up if that helps us. So 5 over 1, technically. X to the fifth over x to the fifth. Y to the third over y to the first. And no z over z to the third. See if you can simplify that one. Go ahead and pause and try it now. There's 2 more properties of exponents that we didn't get to in our table. So the negative exponent property says that for any numbers a and m, a to the negative m exponent equals 1 over a to the m. So up here, technically this 4x to the negative 2y, the fact that this is a negative 2 would drop it down into the bottom of a fraction. So it would be 4x squared y. So 4y over x squared, because the negative drops it down. So x to the negative 4 becomes 1 over x to the fourth. Negative 2x to the negative 2y. I recommend splitting your pieces up so you don't get confused as to what needs to go where. The negative 2 is going to stay on top, as is the y, but the x squared is going to drop down because that's the one with the negative exponent. And then here, again, a little bit more complicated. Be careful to make sure that these parentheses keep this intact. So this is 3x, both of that to the negative 1 power, z over y to the negative 5. Let's see if you can simplify that. And then our last property, the zero exponent property, says that for any number a, a to the 0 power equals 1. It does not matter what a is. So negative 4x, all of that to the 0 power is 1. Negative 4x to the 0 power, no parentheses. Be careful, these are separate now. So that's going to be negative 4 times 1, or just negative 4. Go ahead and simplify this. Again, remember, parentheses keep this together.